What I'm doing here is taking a piece of rectangular tube. What I need to do is taper one end of it where it's narrower than the rest of the tube. You can see my cut lines here. I'm actually going to take a pie cut out of here, out of either side. Now I'll cut the center first because I've got the rigidity of the whole tube to support it while I'm cutting it. And then after I cut this piece, I'll have the rigidity of the sidewall to support this cut here. And that's all I got to say about that. I'm having to stop and restart a lot because this blade's about shot, and when they're shot they drift. This one's drifting a lot, so I'm too cheap to put a new blade in just yet because it still cuts. This is called seamed or welded tubing. It's actually flat stock that is formed into a rectangular tube, and then they weld down the length of it here, rather than say an extruded pipe that doesn't have the weld. Well, because of the forming and the welding, there's a lot of stress inside the steel. You don't see when it's in its natural state, obviously, because it's all being held together. So everything's spreading open now, and it's looking pretty bad, but in the end we'll get it all formed back together and get it straight. Imagine a piece of rope. When you put a lot of tension on a piece of rope, it's got stress built inside the rope, and then if you cut the rope, it pops and retracts, relieving all that stress that was in the rope when you pulled it tight. It's the same thing with the steel. When it's formed, it has stress inside of it, and you start cutting it, it starts relieving those stresses, and things start moving around, and you get that. Alright, ready or not? There it is, all tacked together. Now I just got to finish weld it and then grind it smooth. Okay, I got it all tacked together, ready to weld it now. I ground out the edges before I started welding so I'd have some room for some weld. If they were just tight butt jointed together, then you wouldn't get very good penetration. So I ground it out a little bit for the weld. I turned up the heat on my welder a little bit so I'll burn into it deep. And if everything goes well, we should have a good solid weld here. You notice I'm pulsing the weld rather than a continuous weld. Because I ground that V to get better penetration, there's some open areas and some pretty thin wall. If I were to go with a continuous weld, there's a good chance it would blow through. So I'm just spotting as I go along to allow it to cool off in between each draw so it doesn't blow through. Try to minimize the heat in one given area as much as I can. Okay, it's all welded up. There's a little more spatter on it than I like to see, but like I said, I set my heat pretty high to get good penetration, and we're going to grind it all off anyway. So looks like you got good penetration, all filled in. We should just be able to grind it smooth and make it look like it was that way originally. Okay, that didn't work out as well as I hoped.
No?
This is a finer grit. Now you can see the witness marks from the weld are starting to disappear. Get my radius back in there. Then after this I'll go with a finer wheel. Get it smoothed up even better. Here you can see where I rough ground it. You can still see the edges of the weld. Witness marks from the weld. And then over here where I've started the finish grind, you can't see the weld anymore. It's starting to blend in just like the radius on this tube here. I'll do this side and then I'll go to a finer wheel and polish it up real nice. I'm using a Scotch-Brite pad that'll just kind of polish things out. There it is. Can hardly tell it was ever welded. Ta-da!